I was just absolutely floored by this new Hubble image that came
Oh,
out.
Todd.
It's this amazing face-on view of a spiral galaxy,
Yeah.
NGC 3596.
Ah, NGC 3596. Yes, saw that. Truly stunning, isn't it?
Holy
90 million light years away out in Leo. And seeing it face on like this, it really lets you appreciate the structure.
It does. It's incredible.
And, fun fact, William Herschel actually spotted this one way, way back, 1784.
No kidding. 1784.
Yeah, but obviously not with this kind of detail. This new Hubble view is just something else.
Exactly. It feels like we're seeing it properly for the first time. So that's kind of our mission for this deep dive, right? Let's really dig into this image, soak up the beauty, but also maybe unpack some of the cosmic puzzles it presents.
Sounds great. Where do you want to start?
Well, looking at it, what just jumps out immediately are those arms, those swirling spiral arms. They're glowing with these really vivid pink areas, and then they're just speckled with bright blue stars.
Yeah.
What's going on there?
Right. So those pink glows, that's basically star formation in action. Active stellar nurseries.
Nurseries, okay.
Yeah, you've got massive amounts of hydrogen gas, and the intense ultraviolet light from brand new, really hot blue stars is ionizing that gas, making it glow that characteristic pink or reddish color.
Ionizing it,
Yeah.
like stripping electrons.
Exactly. And those blue stars themselves, they're the newborns. Very young, very hot, very massive. They haven't had time to drift far from where they formed within those arms.
Cosmic nurseries.
Yeah.
I like that. But it makes you wonder, how do these arms even, stick around? They look so defined, but they can't be solid structures, can they?
Yeah, precisely. That's one of the big enduring questions in galactic astronomy. How do spiral arms persist?
Right.
And it's not simple because galaxies show such variety. You see some spirals with these really tightly round, clear arms. Others are more flocculent, like patchy and less defined.
Succulent.
Yeah. And then you have bars across the center, or no bar. Bright central nuclei or not so bright. Some galaxies are isolated. Others have companions interacting. It's complex.
The whole galactic zoo out there. But wasn't there this idea, the winding problem? What was that?
Yes, the winding problem. That was the initial puzzle. If you imagine the arms are just made of stars and gas orbiting the galaxy's center, well, stuff closer to the center orbits faster than stuff further out.
Like planets around the sun, yeah. Kepler's laws, sort of.
Kind of, yeah. Differential rotation. So if the arms were just fixed collections of material, the inner parts would wrap around much faster than the outer parts.
Okay.
And pretty quickly, cosmically speaking, the whole spiral pattern would get wound up incredibly tightly and just smear out. It wouldn't last for billions of years like we see them.
Right, like stirring cream into coffee eventually just blends. So if that's not it, how do they keep their shape? What's the current thinking?
The leading idea now is that spiral arms aren't fixed objects, but rather density waves.
Density waves, okay.
Think of it like a traffic jam on a highway. The jam itself, the region of slow, bunched-up cars, might move slowly along the road or even stay in one place for a while.
Right, I hate those.
We all do. But the individual cars aren't stuck there forever. They slow down as they enter the jam, move through it, and then speed up again on the other side.
Okay. I think I get it.
So the spiral arms are like that traffic jam. They're regions of higher density, a wave of compression moving through the galaxy's disk.
So stars, gas, dust, they all sort of pile up temporarily in the arm.
Exactly. They slow down as they enter the wave, which compresses the gas and triggers that star formation. We see those pink nurseries and blue stars.
Gotcha.
But then the stars and gas continue their orbit and move out of the arm on the other side. The arm itself is a pattern that persists, even as the material slows through it.
Wow, that traffic jam analogy really clicks. So the arms we see in this gorgeous NGC 3596 image aren't static things, but these dynamic waves passing through, causing bursts of star birth as they go.
You've got it. It's a snapshot of this incredible, ongoing cosmic dance. It's a process frozen in time by the time it takes light to reach us.
It makes the image even more amazing, thinking about the dynamics behind the beauty.
Absolutely. And studying galaxies like NGC 3596 in such detail helps us refine these models, understand how these density waves get started and what keeps them going.
This has been fantastic. So recapping. We've got this breathtaking Hubble view of NGC 3596 face-on, showing active star birth in its arms. And these arms aren't fixed, but likely density waves, solving that old winding problem.
Precisely. It highlights how much we're learning, but also how much is still, a bit mysterious.
Yeah.
Which brings us to maybe a final thought for you listening. When you look at an image like this, remember, it's not just a pretty picture. It's a dynamic system, constantly churning, constantly evolving. Think about the immense activity star birth, stellar orbits, density waves propagating, all captured in what looks like a serene, almost static object millions of light years away. It reminds us how much complexity and, frankly, how many unanswered questions are hidden within the beauty of the cosmos.